So as he mentioned, I'm Marcy Sutton. I'm here to tell you about accessibility and performance. So things that you could do to make websites not just look like they're loading fast, but actually perform fast, make them so they behave quicker. I can be found on Twitter at Marcy Sutton, and I've just tweeted a link to these slides. So if you want to take them, if you're more of a designer and you want to go share this around to your development team, it might be a good resource for that. I work at a company called DQ Systems, which is headquartered in Virginia, but I live in Seattle. So I work remotely on accessibility tools, which I'll tell you about a little bit, but the focus of this talk is more on performance. So who am I, other than the person who forgot to start their grunt server before their talk? I work on an API and set of browser extensions called AxeCore, and it's something that you could use to quickly assess the accessibility of web pages. So an audit tool that can help you find problems quickly so that you're not poring over the source code looking for incorrect ARIA attributes or something really like a minute detail. I co-founded a web accessibility Slack channel that you can find if you just Google web-A11Y, you'll find this Slack that's been funded by Slack because it's a really great nonprofit utility that the Slack team themselves have been using to get accessibility feedback. So you could go in and find accessibility experts to ask a question. If you're ever wondering how to do something or how to design something for accessibility, you could join us in Slack. I work on the Angular team, mostly now just as a consultant so that they're thinking about accessibility, but in the past I worked on the Angular material, the UI framework, so really JavaScript heavy, building a lot of accessibility into it using modern technologies. I have also, for the past 2 years, been co-leading the Seattle chapter of Girl Develop It, which is a nonprofit encouraging women to get into software development. I'm going to play you a video of VoiceOver, the screen reader on Mac, loading CNN.com in Safari, and you'll see what this experience is like for a person using a screen reader who maybe has a visual disability, what it's like when a very heavy web page loads in a screen reader.
VoiceOver on Safari. Favorites window. Toolbar. 78%, 84%, 85%, 88%, 89%, 90%, 90%, 90% loaded. 90%, 90% loaded. 90% loaded. 90% loaded. You are currently on HTML content. To enter the web area, press Control.
So that's what that experience is like. As you could see, there was a lot of visual information coming in on the page. There's a lot of ads, there's a ton of links, a lot of content. And as you're getting visual feedback, the screen reader is still struggling to get a full load so it can tell you what's on the page. So not only are sighted users impacted by slow performance and heavy web pages, people using assistive technologies also are impacted by this. So today we're going to look at how you could try and address this problem and try to make websites actually perform faster, make them functional faster, and not just look like they're loading faster. So in performance in web development, and this is a bit of a warning that I am a developer, so it's more development stuff than design stuff, but I'll try and keep those things balanced. For me, web performance, I think of waterfall graphics like this and the research by people like Steve Souders, talking about how you can optimize all of these resources that you're loading in web pages to try and figure out what the slowdowns are. What assets are taking forever to load, and can we optimize those? How can we get into this science of making web pages perform faster? And then there's accessibility, which in general terms means that you're making web pages and web apps and experiences that work for everybody. People with visual impairments, people who can't use a mouse, just really extending those experiences to include more people. And I'm really passionate about that. It helps me feel like I'm contributing something to the world. Like, it's worth getting out of bed in the morning. I love accessibility for that. So the people in these audiences, who are we actually talking about when we're looking at something like accessibility? We're talking about people with limited mobility. Maybe someone has MS, or maybe you broke your arm, maybe you're holding a baby today. Like, you could have all of these reasons why you have limited mobility, not just people with disabilities, but there are a lot of people who physically cannot use a mouse, and so they rely on the keyboard. We're talking about people with blindness, low vision, color blindness, visual impairments that either you could be born with them or they could degenerate over time. We're talking about people with cognitive and learning disabilities, people with autism who might need more time or plainer language to try and understand what's going on web pages. And we're talking about people who are deaf, hard of hearing, have some maybe degenerative hearing loss, which I'm starting to feel a little bit from listening to music too loud. But everybody else too. Like, you'll find you're either in this one of these groups in some way, either you aren't now or you will be later, or you know someone who is. So accessibility is often forgotten. It's sometimes tried to shove in and bolt on at the end of a development process. But we need to be thinking about it sooner because it really hits on so many different kinds of people. So how do these two things come together? What does accessibility have to do with performance, and how can we actually make any movement in this space? We could start by making accessible interfaces to begin with. And so I'll try to fill in some of these gaps in this talk. It's not an accessibility 101 talk. I have some resources at the end if you're really new to accessibility that'll help you learn where to learn more information. But we should be making accessible interfaces to begin with. So getting it to perform faster is sort of an add-on with the caveat that you're already making accessible interfaces. I'll try and highlight some of those things today. We want quicker operability. So we want things to perform faster, work quicker for keyboard users and screen reader users. We want fewer steps to task completion. So if you have a user interface with steps that a user needs to take, they're using a keyboard or some input device, can we streamline the number of steps that someone has to take to complete a task? Because as I will tell you in a little bit, there's a lot of cognitive overhead for a user to try and complete these tasks. So that's another way to think about performance. In my research for this talk, I kept coming up against this quote: "You can't optimize what you can't measure." And this comes from Google's Web Fundamentals on performance and the critical rendering path, which I'll show you a little bit more in a minute. But it really got me thinking, okay, well, if I'm looking at performance and I need to try and optimize and measure things, where does that leave me for accessibility? There is this great API called the Navigation Timing API, and it gives you all of these metrics that you can start diagnosing how long things are taking to load. And in this graphic, it's split up between the pieces that are network-specific, server-specific, and client-specific. In accessibility, most of the stuff we're going to talk about focuses in this client area, so the browser loading things as opposed to the server. Frameworks like Angular, React, Ember, those are all really client-heavy, which you may or may not already know. But we're going to focus mostly on the client. In this timing API, there isn't really anything specifically for accessibility. There is this group of items, including DOM interactive. So at what point can we measure that the actual page, the document object model, when is that ready? And can we make that faster? So I wondered, what more do we have? And I thought, well, we really want to know when that screen reader can be reading a page. And so I looked into this, and a friend of mine, Marco Zija, wrote a really great blog post about why he does not want to be tracked as a screen reader user. He's saying that letting a website know that you're using a screen reader means you're running around on the web, waving your white cane, going, hey, I'm disabled, where otherwise it's the one place that people with disabilities can go relatively undetected without their guide dog, without their white cane. And so they're very protective about their privacy. So currently we don't really have ways to track whether screen readers are running, so we don't have those metrics for performance. So what do we have? Because that's basically what I came to in this talk was, okay, well, what do we have? We have known user impact. We saw that video of CNN loading really slow and the screen reader taking a while to get to 100%. So we know that there's impacts on users, and we'll look at these, I'll break these down. We know that there's optimizations that we could do to make these things faster. And then there's this new technology or new approach to building really client-heavy websites and web apps with frameworks like Angular or React. There's a technique of building web pages now called universal apps, and I'll tell you about that. In researching for this talk, I also found a really interesting research paper. It has kind of a funny sounding title of the keystroke level model for user performance time with interactive systems. And it really got me interested in thinking about how long does it take a user to perform a task? Not just how long does it take for the computer to load everything, but thinking about it in terms of user experience. how long does it take a user to actually complete this task? And this research counted the number of keystrokes it took an expert level user to complete a task. But you think about an expert level user, they already know what they're doing, they're pretty proficient. What about someone who isn't an expert user? How long is it going to take my grandmother to complete a task when she's new to technology? And it really just broke my mind open. I felt like this conspiracy Keanu meme saying, what if performance is actually about the limit in your human memory, not the computer memory trying to load all these assets? So that really got me thinking about this completely other way of looking at performance and accessibility, making things simpler so that we're not putting all of this cognitive load on the user. So some of these user impacts. The first thing we're going to look at, the way that slow-performing websites impact accessibility is if you're relying on the keyboard. You're trying to tab through a web page, try to start typing, and things are loading and they're really slow. Are you waiting for JavaScript to load, or are there a bunch of resources that are going to impact the page and that's why it's slow? Is the act of waiting for those resources, does that mean that the UI thread in the browser is just completely locked up? Because you're just trying to load too much at once, and therefore you're delayed in being able to interact with the page. Does the UI depend on JS for everything? Are we loading everything with Angular? And having worked on a framework, I always felt like that was the elephant in the room, where we're really relying on JavaScript to build everything. And so we need to ask ourselves, how much of that can we actually load from the server up front? Are there ways that we can simplify? And do you even need a UI framework? An important question to ask. I found this blog post called "Maybe We Could Tone Down the JavaScript." And when I shared this around, I don't think I was everyone's favorite person, but it really showed me this user impact. The quote says, "I keep spending 20 seconds staring at a page that has not yet executed the bulk of its code. And the images of a tweet detail, and all of the items highlighted in red rely on JavaScript to work." Where some of these items could be anchor links that gracefully degrade to work on a server without JavaScript. There are some core functions on every web page that probably don't need JavaScript, but yet we use JavaScript to build everything. So it's important to ask yourself, what are the core functions of your web page, and do you really need JavaScript to build all of those? So that's keyboard impact. Like, how long does that take for the UI thread to become available for you to be able to start interacting with a page? If you're using an assistive technology like a screen reader, like VoiceOver, as we saw, you might be waiting for JavaScript to build the page as well, and that will impact a screen reader, as we saw. What is that loading experience like? Are you hearing the screen reader count to 90%, 90%, 90% while it's trying to load everything? Is the accessibility tree slow to update? And if you're going, hold on a minute, what is the accessibility tree? I got you. The accessibility tree, like the document object model, is a parallel structure created by every browser. Every browser has their own accessibility tree, and it's a group of objects. So everything in HTML that you create, a button element, an article element, these all have types. They're objects, essentially, and those are what get announced to a screen reader. Most of them use this accessibility tree. Well, these objects are impacted by HTML, CSS, JavaScript, so you can modify this tree on the fly just by changing the display of things. Maybe you're changing ARIA attributes, if you've heard of that before. That's a set of standard attributes that you could use to manipulate this structure. You can get a view of it in Chrome if you go to Chrome://accessibility. That is one place that you could go and look at the accessibility tree. We're currently asking for more tools like this, and there is a Chrome Canary experiment that floats up some of this work. There's a new utility in the Edge browser that's coming out that they announced at Build. Microsoft is doing a lot of really great work to get these sorts of tools in browsers, because this is useful to help you debug, so you can see what exactly is this accessibility information, and how can you even see it if it's sort of this hidden structure. So I'd like to show you this to get you familiar with this idea so that you know that there is this other structure that you should be thinking about with all of these web pages loading slowly. And because I'm super geeky, I wanted to know when the accessibility tree is ready, at what point in the browser's rendering flow does this come about? So when I was learning about web components and the shadow DOM, I first became familiar with this article called How Browsers Work. And I learned a lot about the browser's rendering process and all of these different places that things become available. And the accessibility tree becomes available about the same time as reflow. It's called layout in Chrome, reflow in Firefox. But this is part of a rendering engine flow, this is where that structure gets created. And so it's impacted by a lot of the same things that reflow and layout are. So if you're really getting into performance, you might have looked at things like what affects repaints and what affects, how the browser has to redraw everything. So some of these things that actually impact that accessibility tree structure, if you change things in JavaScript, there's a list of things that are known to impact these. Things like display none, which is a really great tool for accessibility. If you have a section of a page that's visible and then you want to hide it, using display none is really great for that because it'll remove it from the accessibility tree. So a screen reader will just skip right over it. It's a good one. It's just important to know that it impacts layout. Things like looking up an element's computed role or its computed name can impact layout and reflow. Doing fancy things with scrolling, like if you're trying to hijack scrolling on the page load and you're trying to do a lot with JavaScript, that can slow things down in the accessibility tree. Doing expensive lookups like window.getComputedStyle. I used that in a UI framework and then quickly learned how expensive of an operation that was because you're having to go and query an element in the DOM, figure out what its style attributes are, and then to be able to do anything with that, you just want to make sure that you're doing, if you are going to use that, you do it at a time that it won't matter that you're doing an expensive calculation. So not right at page load. That's the time when you don't want to look that up. But there's much more, and these all come from a really great gist by Paul Irish that you can pull out of these slides. I encourage you to get familiar with this. Okay, so that's admittedly some pretty geeky stuff, but I am super fascinated by these kinds of things because that's how we make this better. So what are some optimizations that you could do? We're kind of pushing on browser vendors to give us some things like an accessibility tree readiness event, but as a developer or a designer, what are some things that you have more control over that you could do? So the first thing I'm going to tell you is use as many browser defaults as possible. And I know as designers, it's really tempting to want to create your own visual language for everything and restyle everything. Have an honest dialogue with your developers about what's possible. Or if you are a developer and you're getting all of these custom designs for things like select menus, really push back and ask if it's necessary. Because I will tell you from having worked on a UI framework that it's really, really hard to do it right. It's really hard to make it accessible. It's hard to make it work on mobile devices, cross-platform. So there is a big cost associated with deviating from these browser defaults. I'm not saying it can't be done, but you really want to think hard about it. So things like buttons and links, they have behavior that comes with those elements. You get tabability from the keyboard. You have things like history with links, hrefs to open up new documents or new pages. And it's really important just to think long and hard before you try and deviate from these, because you get a lot for free. Same goes with HTML5 inputs, like things like, let's see, well, the select element, as I mentioned, that's a big one that people like to restyle. It's really hard to restyle, so we tend to try and create a custom one. But if you can use any of these for free, or use these, you get so much for free that it's worth considering. Focus styles, which is a constant battle because people hate the default browser focus style. At least replace it with something, but this one is also pretty hard. And in looking at these things, I'm always filing bugs in browsers, trying to fill these gaps where the reason why we tell you not to deviate from the defaults is because of what you get for free. But that's often because we want to be able to restyle them. So we're actively trying to push on browser vendors to make it easier for us to style these things, but right now it's a bit hard. And the reason why this is an optimization that you could consider is because everything you customize in CSS or JavaScript has to be sent over the wire. If you're looking at a web page on your mobile device, you might have limited data. The time it takes to download, the amount of stuff you're downloading, it takes time to do that, and it has to be sent over the wire. So it comes at a cost. Everything that you redesign and try to make accessible and cross-platform comes at a big cost. So these are just trade-offs that we have to consider. So the next optimization for making things perform fast, not just look like they're loading fast, is to include keyboard support in the critical rendering path. So in performance, they talk about, chunking related things that are important to view things above the fold. Like that first load, what's the most important thing on a web page? Make that CSS and JavaScript load first. I would encourage you to try and add some keyboard support in that initial load, because it is important to be able to start interacting with a web page. So prioritizing accessible interactions. An example is Tumblr. I have a Tumblr blog, which I'll link to at the end of my slides, but I was trying desperately to log into Tumblr on hotel Wi-Fi. I don't know if you've been there trying to log in on slow Wi-Fi on a site. Their modal window to log in requires JavaScript to do everything. For some reason, it just would not download the resources I needed, but I got a full screen animated GIF. So the priorities were a little backwards. So as a user, that's super frustrating because I have a big full screen GIF, but I can't log in. So the core function of the site just would not happen fast enough. So another technique that you could use to try and make the space better, especially if you're working in client-rendered frameworks like Angular, Ember, React, is this idea of universal rendering, aka isomorphic JavaScript. And the idea with this is that you're loading the same application from the server and the client. And I'll show you what this looks like a little bit. So isomorphic JavaScript, which you can pick whatever name you want. I think they landed on universal. But you first render an HTML page from JavaScript, or that's traditionally written in JavaScript. You load that from the server. So using Node.js, you can actually have a server load up this web page that's written in something like Angular or Ember. The browser will load the full HTML, and then when JavaScript, once those client-side JavaScript files have been downloaded, it will rehydrate the web page and optimize everything with JavaScript. So it's sort of an upgrade that it does. So there's that split moment of time before when it's loaded from the server and then when it has rehydrated. Like, that's a pretty critical time. This starts to get into frameworks, hotness, and buzzwords, and I totally get that. I still think that it provides a lot of value, so that's why I'm telling you about it. So if you are going to go down this road, I have some best practices that I found just from looking at things that use this technique of universal rendering. The first one is don't hide the content when the page loads. I found an example. I follow a really great newsletter called JavaScript Weekly, and in this weekly newsletter, one of the weeks, maybe a couple months ago, said a React universal blog. And I went, cool, I'm looking at that topic. I'm gonna go check that out and build it and see what's going on. They, in this application, include a CSS class called Hidden, and it comes in from Bootstrap. It has display none important on it. And if you remember from earlier, I mentioned display none is really great for hiding content from screen readers. Well, guess what? That's what it's doing when it serves it up from the server. So you're sort of negating the whole point of the server rendering, which is that you're hiding it on load. When it finally does load, that CSS class goes away, and then the content becomes visible. There's no point in doing a universal app if that's the way that you load it. So a quick fix would be change the display none to maybe opacity 0. That is a CSS property that the content will still render, but you're not hiding it from a screen reader. You're just changing the visibility using opacity. That would be one way to solve that. So another way, or another view of this blog, in the iOS simulator, there's an accessibility inspector that you can turn on. And when the page first loads, it's blank. So there is no accessibility information there. The accessibility tree is just, there's nothing there. On the right, after it's loaded, you can get the content, you can start to interact with it. So we want to make sure that if you're going to use this technique, that it's visible. Because then, if it is visible, it will be a seamless experience from one to the next. You should also consider using progressive enhancement. And somebody who does this really well, and of course they do because isomorphic JavaScript came from Airbnb. On Airbnb, they do a really great job of enabling core functions of their website. And I never thought I would be in this camp, but if you don't have JavaScript running, you can still search Airbnb. You can type in, I typed in Seattle, you can have it pull back results because they have enabled the core functions of their site. So part of this performance stuff is it's just making your website available to people in more contexts, more places. People might have JavaScript turned off. So that's one huge advantage of using this server rendering for these traditionally client-rendered apps, is that then you can do things like this, where your site still works. It's not that it just looks like it's loading fast. It's actually loading, and then you can have things work. It might not have every feature, but at least the core functions, and I think that Airbnb is doing that really well. Something that you should also do is utilize this library called Preboot. It does this thing called event playback. So I talked about browser rehydration, and so when you're serving this web app from the server, if the user starts interacting with it before it's actually upgraded, what happens? And I really like this library called Preboot because it handles that. It will keep track of what the user typed, where their focus was, and the goal of it is to play back those events so none of that user input is lost, so that the focus can be resent into the JavaScript loaded page, because otherwise what happens, and this gets into something called focus management, where you're a keyboard user, you've tabbed into somewhere like a text area maybe, and when the page reloads, poof, your focus is gone. And if you're a keyboard or a screen reader user and you can't see where you are, that's really important for us to handle their focus. And so this Preboot thing combines all of these great ideas to actually make universal rendering something that's really valuable. And it makes it so that, I mean, you're going to be writing these client-rendered apps anyway. Like, this might not be the most popular idea. Some people just say, you should just make a Ruby app and be done with it. But things like Angular apps are happening. This is stuff that we need to handle. So by using something like universal rendering with Preboot, we can make this more of a graceful user experience. So in conclusion, you want to think beyond visual performance, as I mentioned. You want to make sure that things load fast and perform fast. By optimizing for accessible actions, you'll make it so that a user can actually start typing on the keyboard quicker. They can start interacting with your web page quicker. And then you want to simplify your interfaces, making sure that there aren't too many steps for a user to complete and you're not losing them in the process. So it's part like loading and assets and downloading and JavaScript, but then also really pushing back on design to simplify and make less steps so that you don't lose somebody. You want to use technology to help more users. And there's different ways that you can approach this problem. I'm coming at it from the development side, but you could approach this from the design side too. So what I love about accessibility is that you can actually help people. You can actually make the web more of an accessible place just by using some empathy. And this might seem like sort of big dreams and small potatoes, but it is really important to make the web perform faster for people. So some resources. In case you're new to accessibility, I know this is more of a design conference, so I've included a link to WebAIM is a really great organization. They have a checklist called Web Accessibility for Designers, and that stands for Web Accessibility in Mind, if you're going to type it out. But that's a really great resource to know what kinds of things you should be thinking about if you're a designer. Also on WebAIM, they have a lot of really great tutorials for using screen readers, things from the development point of view as well. I created a blog called Accessibility Wins that you can go and look up to find cheerful, happy ways of looking at accessibility, because sometimes it's all about what you did wrong or you got sued or something. And I think it's much happier to go and look at what's being done well. So I felt that there was a gap out there for keeping track of those kinds of things. So I catalog them. If you worked on something that you really like or you're proud of, you could send it to me and I'll feature it on my blog. The A11Y project or accessibility project, if you're ever wondering what A11Y is, it's a numeronym for accessibility. That's a really great resource that you can contribute in open source. You could go and get ideas. There's patterns on there you can go and check out. And then lastly, the Axe Chrome extension that I work on. There's a Chrome extension and a Firefox extension, and the idea is that you can just quickly run an audit on a web page, figure out what's wrong. That's usually my first step to diagnosing something. So that's it. You can find me on Twitter and GitHub at Marcy Sutton. Thanks. And I am done really early, but that's okay. We
Do
have
you
more
want
time
to
for
do
questions.
some? Do you want to do some Q&A?
Yeah, let's do some Q&A.
Cool.
Yeah. Yep. Yes. Yeah. So there's the Slack, and then there is a, I think it's Heroku app. That is a public login. Do I have internet? Yeah, it should load. So the URL is web-a11y.herokuapp.com. And so that's where you can go to just go and log in. We set that up to be open so that people could get in without having to come and knock on the door all the time. Yeah, so that's where you can find it. Thanks. Sure.
Is there any impact of screen reader when you do progressive coding? So in other words, you just load what you think the user can see on the screen, get it ready right away, and then load the rest.
Yes, there is some precedent for that would be on Target.com, for example. They had a very long, heavy page, and it would load in chunks. And so to make that a better experience for a screen reader user, they would put an actual note in off-screen text at the top that would say, this page is loading, or this page is not fully loaded. And then as each block would come in, they would use maybe an ARIA live region or something to notify the user that more content had loaded. So yeah, that is a concern. So when a user first comes to a web page, they're probably going to check all the headings, check out the structure of the page so that they know what they can navigate. And if the content isn't all there yet, then yeah, that's something that you would want to add in there. At least some notes, maybe some links to load the more content, things like that. Okay, that looks like it. Gave you some time back. Thanks.
Okay, well, we've now got a 25-minute break, but it's probably more like half an hour.
Well, let's take the
you got
question.
more questions?
Yeah.
Sorry.
Yes.
The resources were some of them, but other things that I need to learn. I know there's a lot.
I would say the first thing that you should do, are you more on the design side or the development side? Design side. I would definitely look at this checklist, and I can just pull it up. It's an infographic that has like everything you would need to know. So that would be a really great overview of things to consider at first. But to gain some empathy, I would just start navigating with your keyboard. See how quickly you have to bail and use either the trackpad or the mouse. And every time you have to do that, it's a place where we could make an improvement, just to better support a keyboard so that you know where you are on the screen and you can actually complete all of the tasks. So that would be the first thing. Like before you even get into screen reader testing, you could probably cover a lot of it just by navigating with the keyboard. Cool. One more.
Do you have any recommendations on how to get bosses or employers to make accessibility a priority in the development timeline?
Yes. So I come at it more from the it's the right thing to do camp. But I know that sometimes what makes movement is legal action. So there is a big risk. If you were at a big company, you can always, I don't really like this approach, but you could always say, hey, there's a legal risk. And depending on your industry, there is precedent for a lot of companies getting sued now. And that is, sadly, that's how a lot of accessibility things get fixed. But there is a lot of the legal risk. There's technical debt purposes. Like the longer you go without adding accessibility stuff, the harder it's going to be to do. Like, what would you say if they came to you and said, we're going to do mobile in phase 2? Like, that would not work, right? That would be a lot of rework. You'd have a lot of technical debt, and accessibility is the same way. So if you do it earlier, like in the long run, you will save so much money, especially if you get sued. So those are a couple ways that I try to convince people.
Market share is another really good one. But, we lose out a lot of market.
You do, yeah. There's, so you can encourage people to consider it because you can get more business. People with disabilities are your customers. You just aren't allowing them to be your customers by not making your site accessible. So yeah, that's a really great reason too.
Any more questions?
think we're good. You can always come and find me, or find me on Twitter too.
Okay, thanks a lot.
Thanks.